Hello, I'm Rob Reiner from Tachyum. Today we're going to showcase our latest milestone by demonstrating machine check and recovery capabilities of our Prodigy Universal Processor in its interaction with the Linux Error Detection and Correction Subsystem, or EDAC, running on our FPGA emulation system, which runs the actual Prodigy design. The machine check and recovery purpose is to detect and, if possible, seamlessly correct errors in the CPU's internal memory blocks and attached DDR modules caused by external events. Events like these are extremely rare, but large-scale deployments with many processors, which you find at a typical data center, increase the probability. Correcting those errors helps running prolonged workflows without interruption. When the degree of SRAM damage is beyond repair, detecting the error condition is even more essential. It's better to abandon and repeat affected computations than provide the wrong result. The MCR subsystem of the CPU paired with the Linux EDAC driver provides the level of reliability and availability that is essential for today's demanding data center applications. Integrating these capabilities is a part of the overall polishing of the Prodigy design. This ensures full integration and testing on the FPGA emulator before tape-out later this year, facilitates a smooth ramp to production, and ensures quick, easy integration of Prodigy into existing data center solutions. The natural occurrence of bit flips in memory cells is rare and unpredictable. To verify that both the CPU and software driver handle the situation correctly, we created error injection mechanics which simulates the same damage to the memory content. Our error injection module can inject both correctable and uncorrectable errors into relevant CPU blocks, and it can inject either a limited number or continuous stream of errors with programmable intervals. Various blocks provide different levels of detection and correction depending on its size, average expected lifetime of transient information, and whether the correct value can be retrieved from other sources. For the largest and thus most error-prone memories like L2 cache and DRAM, Prodigy provides DECTED, or double error correction with triple error detection. In addition, the Prodigy hardware performs patrol scrubbing of memory as a preventative feature, periodically cycling through memory with read operations to find and address any correctable errors as soon as possible. Logging the amount and rate of correctable errors with the EDAC facilities of the OS provide plenty of information to proactive administration teams and allows for preventive maintenance to keep data center uptime incident-free for as long as possible. In our demo, we're demonstrating that Prodigy can correct memory errors caused by our error injection module, report the event to the OS, and that the EDAC subsystem reacts and logs those events. For this demonstration, we will use memories of the Level 1 D-cache. On the screen, you see an open session where Linux is pre-booted and is waiting for us to start. Now we'll trigger some limited number of errors being injected by our error injection module. As you can see, the injected errors were detected and system log messages appeared describing the affected CPU block, type, and location of the errors. Since we injected correctable errors, software was completely unaffected and didn't even know that there were any errors. System log entries are the only side effects. In unrecoverable errors, a more drastic measure would have been taken by the OS, ranging from terminating the affected process or even full system reboot to start things from a clean slate. Error injection is an essential part to test not only hardware but also EDAC software that is performing as specified in various situations that Prodigy can encounter in the field. The MCR EDAC pair working together is critical to provide information for predicting and mitigating failures in the field, which is key to maintaining and improving uptime for systems deployed at scale. That concludes our demo. Thank you, and be sure to stay tuned for future Prodigy updates and milestones.